Okay. Um, so this one is over 1 over cosecant theta, and this is 1 over sine theta. You should know that from pre-calculus. 1 over secant of theta, 1 over cosine theta, 1 over cotangent theta, 1 over tangent theta. Any questions here? You learned that from last year in the AP pre-calc. This is why the pre-calc student from pre-calc honor, then you have struggle. Tangent theta is equal to sine theta over cosine theta. Now, they are not the same. They are not the same. So the first one is reciprocal identity. The second one is called quotient identity. Quotient is involved with sine and cosine. This is cosine theta over sine theta. Am I going too fast? All this is going to help you for the next one, which is you don't need to know this proof in terms of green. The green proof is basically it's coming from geometry. And there is also a data, there's an A, there's a B, there's C. Okay? And we know in geometry is A squared plus B squared equal to C squared. Is that okay? This is geometry. Then we say, hey, how do I change geometry to trig? I can take this function and I can divide it by C squared. And that's equal to opposite over hypotenuse square plus adjacent over hypotenuse square that's equal to 1. Right? Because this is the opposite, would you say? This is the opposite of theta, this is adjacent of theta. And this is sine square theta plus cosine square theta is equal to 1. So that becomes the first trig identity in terms of Pythagoras. And this becomes the sine square theta plus cosine square theta is equal to 1. It's actually from a squared plus b squared equal to c squared, but we do it in terms of ABC divided by everything by c to figure out what this is. So that come out of first Pythagorean identity. After that, you're going to come out the other two. But how do I come up with the other two? I'm going to use the same thing. So I'm going to take the same function, sine squared theta plus cosine squared theta is equal to 1, and you're going to use the red function on the top. You can divide it by a cosine square first. If you divide it by cosine, what is sine over cosine? So it'd be tangent square plus 1, because cosine over sine is 1. Is equal to 1 over cosine is what? Secant square theta. So you come up with a formula. Now this is the thing about this, right? Is square is smaller. You cannot write it as like a big 2. If you write a big 2, now you write down tangent 2 theta, it's not the same as tangent square theta. Sine square theta plus cosine square theta is equal to 1. I'm going to divide this by cosine square theta over cosine square theta over cosine square theta. If you divide it, that's going to give you, I'm sorry, I'm not divided by cosine. I'm going to divide it by sine. My fault. Divided by sine. that is equal to 1 plus, what is cosine of sine? Equal to cosecant squared theta. So that becomes the two other formulas. And that's an easy way to remember this. So I finished Pythagorean, which is most of the formula. The next one, you gotta remember the acronym. The acronym is S, M, S, and then C, S, O. So this for this, and this, and this for this, and this. This means sine, and this is a mixed group, and this is the same sine. And this is cosine. So cosine. This is the same group, and this is the opposite sine. Okay. Is that okay? Now, what I mean by sine mixed group. See, this start with sine. That means I'm going to use mixed group. How do I mix? It's going to be sine, cosine. And then I'm going to have same signs plus. And then cosine, sine. Now, last year in pre-calc, they do have one question on the multiple choice talk about sum and difference. All you gotta do is fill in the A, B, A, B. You're done. So that's they call it a mixed group. It's mixed completely, sine, cosine, and change the order cosine and sine. A percentage group would be sine, sine, and cosine, cosine. So this is sine, cosine, cosine, sine. Am I going too fast or no? Okay, I'm gonna write a second one, use the same logic. Again, I'm gonna write down sine, cosine, cosine, sine. I'm gonna write down the same thing. I'm gonna write down the minus sign because the same sign as before. And I'm just gonna write down A, B, A, B. And then therefore you're done. You're done with both sum and difference. By memorize SMS. SMS. CSO, cosine. Same group. And actually that's easy because this one's actually easier because it's gonna be much easier than that. It's gonna be cosine, cosine. Because start with cosine, you should start with cosine. And you're gonna have AB and AB. Now this is just opposite sign. See that sign is a positive, you end up with a negative because the opposite sign. You start with a negative, is end up with a positive. Again, I'm gonna write down cosine, cosine, sine, sine. If you remember in this order, it's pretty easy. Yes.
Or C on the right. Is that supposed to be sine? Not the right too.
Oh yeah, you're right. Oh man, I messed up. Sorry, that's a sine, sine. Thank you. So you finish majority of formula. The last formula is actually not hard. It's all connected. And this is how you know the connections. For me, that I would know connection by realizing how is it connected to previous questions. If you look at the sine of 2 data, so I'm going to prove sine of 2 data. Sine 2 data, can I be sine of data plus data? Does that make sense? Data plus data is 2 data. Now, can I write down the SMS? So be sine, cosine, cosine, sine. Except I'm going to write down data. I'm going to write down A and B. So it's a plus. Do you see those two are the same? Because they're just different order. So basically just 2 sine theta, cosine theta. So if you know one of them, you can devise another one. Are we good? Okay, how about cosine 2 theta? Use the same logic. Cosine of theta plus theta is equal to cosine 2 theta, right? So it would be cosine, cosine, sine, sine. But it's a plus, so it's minus. So it'd be theta and theta and theta and theta. So would it be cosine squared theta minus sine squared theta? It's all using what you know from the past. It's not like rocket science. It's like math is built from one thing to the other thing to the other thing. It just keep on building. Now there's another two thing here. Another two thing here. And you say, well, what is that two things representing? Well, remember, this is a very important one. And this you can use for conversion. You can convert from sine squared to the cosine squared, or cosine squared to the sine squared. What does that mean? That means this, a lot of time people think this is the other two version, but it's not. If I just subtract sine squared on both sides, I'm going to get cosine squared theta is equal to 1 minus sine squared theta, or sine squared theta is equal to 1 minus cosine squared theta. Now, last year, if you did this, you know this is one way to prove one side is equal to the other side. Remember that proving identity section? Everybody hated it. You had to prove one side is equal to the other side. Then you can actually do this. You can say, okay, cosine 2 theta. I want to substitute this into something else. I want to substitute this with what? 1 minus sine squared theta. Is that okay? And this stay the same. So it'll be 1 minus 2 sine squared theta. We just proved the second one by replacing the cosine. So you can replace the cosine with a 1 minus sine squared. You can also replace the sine. So we're going to keep this one the same. And we're going to change this to 1 minus cosine squared theta. If you distribute, this one becomes 2 cosine squared theta minus 1, because negative times negative is positive. So it'd be 2 cosine squared theta minus 1. You come up another formula. And that's majority things that you're going to deal with Calc AB. I don't just prepare you for Calc AB, I'm going to prepare you for Calc BC, because some of you guys are going to go to Calc BC. Not the seniors, but the juniors might. So Calculus BC here, you're going to deal with sine squared theta. But then you say, well, is anything from before? Truth is yes. Because this is the cosine of 2 theta is equal to 1 minus 2 sine squared theta. And there's a cosine of 2 theta equal to 2 cosine squared theta minus 1. So what I'm going to do is I'm going to evaluate this or this. We can come up with another formula. We're going to start with this one. This one's easy because see this cosine squared. This is cosine squared. Are they the same? So can I just do it on this side? Cosine 2 theta equal to 2 cosine squared theta minus 1. Can I add 1 to both sides? And can I divide it by 2 on both sides? So can I say it's 1 plus cosine 2 theta over 2? Make sure that's not a square. That's a 2. That's a 2. Because I write the 2 is a little bit bigger, then square is a little bit smaller. So that becomes the first one. do the second one. This one is harder to change because you have to do 2 steps. So remember, you start with the cosine of 2 theta equal to 1 minus 2 sine squared theta. And I'm going to move the sign, so it'll be 2 sine squared theta plus cosine of 2 theta is equal to 1. I add it to the other side. I subtract it over. And I'll divide it by 2. So that's equal to 1 minus cosine of 2 theta over 2. So this becomes a formula sheet that generates from one to the other. And you got all this formula you can use for different things. I know this part is boring. I'm sorry. But when you get to actual math part, it will start getting interesting. Usually everything style is always boring. But when you get to later, you're going to see how it's all connected. Right now, we show you the connection between each formula. So one formula leads to another one. Any questions? Now, let's go back. I think you guys are shaking your head, afraid to ask me questions, but you should not be afraid. Because if you're afraid, I'm just going to move on. And if I move on, you're going to get lost. So if you have any question, please do ask. Yes.
B are the same.
A and B are different. It's 1 minus cosine 2 theta over 2 and 1 plus cosine 2 theta over 2. So it's 1 minus, 1 to 1 plus. Yes.
With those, why couldn't we just use the Pythagorean theorem A, the sine squared plus cosine squared equals 1?
Yeah, you're absolutely right about that. The thing is, I wanted to represent a different way. Just like, for example, like here, right? There's a tangent 1 over cotan. Why should I remember sine over cosine? It's a different way to express something. It's used for different type of problem solving. Not like immediately, but it's for different type of problem solving. You're gonna see it later more, but right now, especially if some of you guys go to Calculus AB, you need to be able to take integral of sine squared theta. I have asked smarter students that come into my classroom. I don't know if you guys know Chris Quish?
Yeah,
He's a beast, right? He come to my room. I asked him a question. He cannot do it. The question was integration of sine squared theta, and he cannot do it. And he was like, "This is so easy. How come I cannot figure it out?" But the problem is he need to go back to know. He need to go back to know the power reducing because they forget those simple stuff that matter. Because if when you do it in this formula, you can actually take integration using U substitution. However, not everybody needs that, but for him, he needed because he's very very smart person. And I don't just like I say, I don't just prepare you guys for UCF or Valencia. I'm trying to prepare you guys for if you make the Ivy League. I'm preparing you student for there. I don't prepare for AP exam. That's why my class will be slightly harder. Because AP exam is very diluted. If I want to just prepare AP exam, I can get every single one of you guys pass AP exam with a 5. It should not be a problem. I will start preparing for day 1. But I don't want to do that. I think that does disservice for kids. The service for kids is because math is actually worth more. Okay, so it's actually more stuff. But this is your homework. Somebody want to post on the group chat. We're gonna talk about this. Okay. Do you guys? How many of you guys remember inverse? Raise your hand if you do remember inverse. Okay, good. Okay, so if you don't remember, a lot of you guys don't, which is nice. Which is we're gonna go through it. If you don't remember it, that means I'm gonna go through here. Okay. So a lot of you guys don't know what a sine inverse is. Sine inverse of square root 3 over 2. This is asking if the y value is equal to square root 3 over 2 because y related to sine, right? If y value is square root derivative, what will be a radian? Can you tell me what will be a radian? Raise your hand if you think you know. If the y value is square root derivative, what will be a radian? Sydney? You want to change your mind?
No.
Pi over 4 is going to give you square root 2 over 2. That's Sydney. Pi over 3, good. It's a pi over 3. So therefore, this is just a pi over 3. Is that easy? It's asking question backwards. Yes. What is your question?
Do you only have to put one value or can you put both?
Ah, you're asking a great question. Do you have to put both? There was 2 value, right? But there's a restriction for the sine inverse. Do you remember that? For the sine inverse, there's a restriction from here to here, which is negative pi over 2 to pi over 2. So there's only one value in this case, because on 2 pi over 2 or 2 pi over 3 should be the answer, but it's not, because the restriction is between positive pi over 2 and negative pi over 2. So that's equal to square root 3 over 2. Does that make sense? Yes.
What are the restrictions?
Huh?
What are all the restrictions?
Good. I'm going to tell you that this is sine inverse restriction. And cosine inverse restriction is the top 2 quadrant. And tangent inverse is the same as the sine. Okay. Okay, so let's try this one. E. A lot of people are going to get it wrong. But remember, you have to follow restrictions. Yes.
Pi over 4.
Negative pi over 4. You from Kinch?
Yeah.
Good. Very well. Do you guys get negative pi over 4? Did anybody get 7 pi over 4? Or you think about 7 pi over 4? The problem is not 7 pi over 4, because think about 7 pi over 4 is going to come around here, right? But the restriction is like right here. So think about they are like an electric fence right here. You cannot get passed by. So if you want to go to 7 pi over 4, it's right here. Some people say it's 7 pi over 4. It's going to give you a negative square root 2 over 2. But it's not 7 pi over 4 because you failed the restriction twice. So it's like, hey, I'm going to ask, what's your name again? Cameron. I'm going to ask Cameron. It says, hey, I want you to go to Alabama. And you decided to go to Atlantic Ocean, swim across, go to Cape Town, and then go to India, and go to Hawaii, and go to California, and then come back to Alabama, drive to Alabama. Where you could have just walked to Alabama, you're going to be there way faster, and you're not going to die, right? So therefore, you don't want to go across here to get the 7 pi over 4. You could have said, hey, I come back here to get pi over 4. So it'd be negative pi over 4. And the answer is negative pi over 4. So tan inverse and sine inverse are the same. So can you tell me what's the answer for this one? Not Cameron, I need somebody else. Tan inverse of negative root 3. I know Alex got it. I want to ask which person I want to pick on. Maddie, what do you think? Tahara, what do you think? No? William Tomfield?
Is it kind of taking a shot here? Is it negative pi over 4?
Negative pi over 4?
Yeah.
Okay. Sophia? Oh, not Sophia. Kimberly, sorry. I always get confused. Negative pi over 3 is good. Tangent inverse of negative 1 is negative pi over 4. So this one is actually negative pi over 3. Good job, Maddie. I didn't answer. I usually don't tell people they're right or wrong. I want to ask a couple people. So you should be affirming like this is my answer. I'm sticking with it. Whether right or wrong, I'm sticking with it. The one way to tell the tangent is easier. So knowing those values, tangent of pi over 4 is equal to 1, and tangent of pi over 6 is equal to root 3 over 3, and then tangent of pi over 3 is equal to root 3. And that's the easier way to remember. Okay, that's good. So let's ask this questions here. Now, answer from inside, work toward outside, okay? Alex,
It's a 2 square root of 3 over 3.
Cameron,
I just got punched out too.
Sydney, Kelly, Hayden, right? Hayden, okay.
I have an answer, so.
Same answer as him. Good. Same answer as him. Good. So remember, square root of 3 over 3. Look at here. This is equal to pi over 6. It's actually negative pi over 6. It's same thing as saying negative pi over 6, right? And that's equal to 1 over cosine of negative pi over 6. And that's equal to 1 over square root of 3 over 2. It'll be 2 square root, it'll be 2 over square root of 3. Rationalize it. So it'll be 2 square root of 3 over 3. So 2 square root of 3 over 3. Now, on your homework, please ignore H. Please ignore M and N because those are a problem as a little bit of out of your comfort zone. C will be a good question. Let's look at C. Start from the inside, work to the outside. Only the inverse has restriction now, right? So start from the inside, work toward outside. Stefano?
I haven't. I just wrote down the question. It's all going so fast. Okay. So. Sine.
Neha?
I don't negative pi.
Good. It's a good answer. Sine inverse or sine of 4 pi over 3. What is it?
Negative square root of 3 over 2.
Good. And then the only way to get that is going to be negative pi over 3. So the answer is negative pi over 3. Now, lazy people is going to get it wrong because they think sine and sine inverse is going to cancel. Do not cancel them. You're going to work on through the restriction. So some people it's going to be like, oh yeah, let's cancel. That doesn't cancel. Sometimes they cancel because it's like within the first quadrant. Within first quadrant, they can cancel, but outside the first quadrant, they don't cancel. So you should work out the rest of them. It's good training. I'm going to go to here. Question 4. I'm going to go through example of each. So question 4, let's just go into B, this particular questions here. Now, I have a cotangent or cosine inverse of negative 2 over 3. I'm going to go through this pretty quickly. But remember, cosine inverse is the top 2 quadrant. Did I mention that? Cosine inverse is the top 2 quadrant, right? So if it's top two quadrant, you're gonna have to decide a quadrant. I always tell students draw it out and check which quadrant it's supposed to be. If you don't check, you don't know what's the right answer. So the way I would check cosine inverse first is top two quadrant. Is that okay? And it's negative, so is this the quadrant? Is that okay? So I'm gonna draw a reference triangle with data here. And I'm gonna follow this. So this one is gonna be the -2. Is that okay? This is -2. Because hypotenuse is always positive. You want to write down hypotenuse, always positive. And then you can use a Pythagorean identity to figure out the third side, which is the y, right? So it'll be -2 squared plus y squared equal to 3 squared. So it'll be 4 plus y squared equal to 9, y squared equal to 5, y equal to square root of 5. So you know that this side is square root of 5. Is that okay? Now you have to figure out what a cotangent. So remember, this is the data, right? This is anything inverse is going to be data. So cotangent of data is equal to adjacent over opposite, because it's opposite of tangent. So adjacent is going to be -2 over square root of 5. And you want to rationalize this? So it'd be -2 square root of 5. Sorry, -2 square root of 5 over 5. And that'll be the answer. You can try one for D. Actually, D,
That's an and parentheses.
you can try this one. And you should be able to go through all the questions now, all the way to 4, without doing to 5. The last page can get rid of it. You don't need to worry about the last page, because last page is not some question I will focus on. Those are the questions I'll focus on. Tomorrow I'm going to talk about solving equation. I'm gonna post some because we are kind of cut short. I don't want to fall too far behind for Mr. Ollie, because I already have a longer 7 period on Friday. So she's testing tomorrow. I'm testing Thursday, so I don't want to fall too much behind, because he got extra 2 hours on me. So I'm just gonna catch up a little bit at a time. Because Friday there was longer time in that this class. So. Did you get D? Oh, I said E. Sorry, E. Get E.
That's supposed to be F. There are 2 E's.
You are absolutely right.
Raise the answer B again.
For B,
Yeah.
it's a -2 square root of 5 over 5.
Oh, that second square root of 5 over 5.
It is rational.
Has Thursday to be like we're able to fill it out in also minutes.
No, that's true.
Oh, alright. With that,
And solving equation. Okay, tell your parents to email is more effective than emailing.
Okay.
I'll email them,
Okay.
but it says you didn't have the AP pre-calculus assessment with us. That's what you got. All right, and I'll email them again too, so I'll have a double.
Appreciate it.
Thank you.
Matthew, same way. Same situation.
Yeah.
Your parents will email for you or not?
Probably.
Why not?
I just went over there before
Their confirmation?
your call.
Okay, I'll confirm with, I'll.
Had a pretty decent.
Hi.
On my test.
Oh, yeah, you failed at completing. Just kidding, you didn't. I don't know if you failed. I don't think you did.
Wait, is the test on Wednesday or Thursday? 'Cause-
Thursday.
Oh, whoa, okay.
Yeah, is that nice?
Yeah. Thanks for seeing. me get away.
Carlos
Uh,
said if you get a higher score than him, then you're gonna make fun of him or something like that.
Of course I will.
Oh,
Of course I will.
Yes, you. What happened? What do you want to talk to me about?
I'm just here with him.
You're already 10 steps behind if you're from Miss Shaw.
Yeah, Miss Shaw.
Mhm.
It's okay. I'll be ready here.
Thank you.
Just ask me what question.
Are you understanding what happened today?
Kind of. I'll go home and review.
You had to come after school, not go home.
I started home. Oh wait, oh no, I can't do that.
All right.
Oh,
So
wow.
I can see that it's more than just distractions this time. The pacing is like 2 times the speed I can understand.
Well, luckily there's a video, so there's a YouTube video on that. There's my video, so you can go back and slow down the pace.
Okay.
No, this is supposed people are supposed to know through pre-cap. This is like
Fair enough.
I should not cover this.
I suppose this is just review. I suppose I just
Is
forget
that
the
you?
concepts faster.
You got it.
Okay,
Brad. Have faith.
I gotta go. A few.
Hi, Mr. Ian.
A few.
How you doing, sir?
Yo.
Come here. What's your name?
Avani.
Avani? You're gonna have to come to after school tutoring. And you have to come every single day for you to even like close to survive. Because you already know what happened in your first test. You didn't even come back to do things. I'm gonna make a parent phone call, told them to make sure they come in. You come in. Because their parents had to find a ride. She said she wanna give you a ride, that's awesome. I don't know if she can. But you gotta be the one that says I need to come here to get better because you already behind 1,000 miles. And you have to catch up doesn't mean that you cannot. Anybody can catch up. I have student from Mr. Robinson. And Robinson is probably worse than Shaw. Shaw is alright. Shaw tried to teach. She doesn't know how to manage the class. You know what I'm talking about. Nobody pay attention to her. I don't know why you're not in AP breakout.
Yeah, I have presentation. I did.
It's just they put me in honors, so I stayed there.
The same thing as Chris. But Chris got a 5, but Chris is off chart genius. That was the only person that survived last year.
Do you want me to like take this with me or do you want me to
You
come
can
back?
keep it.
Oh, okay. All right. Thank you. All right.
Bye.